Hello, my name is Cody Glen, and today we're at the Jacobs Institute, and we're going to talk about this Fablight fiber laser behind us. This is a really cool metal cutting fiber laser, and it's in a lot of ways very similar to the CO2 lasers that we have upstairs, and in a lot of ways it's very different. So typically a CO2 laser is usually about 60 watts of power, and it's got an incandescent bulb and a CO2 canister, and that system being focused through a bunch of lenses and mirrors is what creates the laser beam that can actually cut material. This one functions a lot in a very similar way. However, this one has an LED, and instead of a CO2 canister, it's got a doped heavy metal matrix of fiber optic cables that accelerate that light and then collimate it and make it essentially perfectly straight. And that is what cuts the metal. There's no lenses or mirrors or focusing agents in this machine. It's all just a fiber optic cable. Because of that, it means that it is very dangerous at the tip of the tool. It's also very dangerous 6 feet away from that tool. So that means we have to have material in the machine for it to cut in order to not actually burn a hole in the backstop of the actual machine itself. So the typical CO2 lasers are about 60 watts. This one, however, is 4,500 watts. So it's considerably more powerful. Yeah, let's take a look at the bed of the machine. So the bed slides out just like that. It's 50 inches in the X direction this way, and it's 25 inches in the Y direction this way. And then you'll notice too that the slots or the slats in the bed are spaced about 4 inches apart. So that means that the smallest amount of material we can actually put on the bed is roughly a 6-inch by 6-inch square of material. Essentially, we have some clamps here that you can use to clamp your parts in. We want to make sure that we have enough material to actually sit on the bed itself. This machine can do things like aluminum, cold rolled steel, stainless steel, copper, and titanium, and various different thicknesses of those types of materials as well. The maximum thickness for most materials is about 1/8 of an inch, and you can go all the way down to really thin, almost foil-like metals. And we have a database that we'll talk about a little bit later that catalogs all of those materials for you. Also, you'll notice we have some signage here that says metal only, no plywood and no tape. That's because this machine, when it cuts metal, produces heavy metal particulate, and it produces aerosolized metal particulate. So there's no real smoke or other combustible materials. If you put things like wood or plywood or tape or plastics or something like that in this machine, you'll produce a lot of smoke in the space that can't be filtered out, and that's super noxious and deadly. So we want to make sure that we're only putting metal in this machine. And in addition to that, it can only be uncoated, non-painted metal. So it needs to be raw aluminum, raw steel, raw copper, with no plastics on it or anything like that. It just has to be the raw metal. So yeah, that's kind of it for the bed. The bed slides in and it sits in a kind of little dip in the track, a little detent. So as we slide it in, we'll notice that there's one little dip right there. And that spot is in table mode. If we push the table all the way to the back, it puts the machine into rotary mode, which allows you to do things like tube cutting. But today we're not going to talk about tube cutting. We're just going to focus on just doing sheet cutting. And if you have an interest in doing tube cutting or are otherwise inclined to do that, come see me about that, and I'd be happy to walk you through that process. So we're going to press the white power button to turn on the machine. We'll turn on our air to make sure that the machine has compressed air. We'll go ahead and disengage our emergency stop and then turn the key a quarter turn. And you'll notice you did everything right when the light turns on the inside and the machine kind of springs to life. So when the machine turns on, it comes to our first screen. Effectively, we only have two choices here. The first is we can home the machine, and the second is we can continue. If you press continue at this stage, since it's not homed, it's just going to tell you that you need to home the machine. So that's exactly what we're going to do. We're going to click home the machine. It's going to ask, are you sure you want to home the machine? Yes, I want to home that machine. And what it's going to do is on the inside, it's going to move itself around to find the various different limits of the machine so that it can figure out where its home position is. Once it's done moving itself around, we can go ahead and hit continue. And that brings us to our main screen. So at this point, we can choose to run a new job, or we can continue to jog. So we can actually jog the machine around at this point. And when I jog the machine around, it's done by moving these flags around. So as I slide those flags on that screen, it's going to move the machine to where those flags are pointing. You can also, if I double tap on the screen on one of these flags, I can numerically move it. So I can say, I want to go to where exactly 25 inches and hit done. And then the machine will move to exactly 25 inches. Or we could try maybe 10 inches. And then the machine will move to exactly X is equal to 10. So that's simple jogging. There's some additional options here, but you don't really need to worry about those. We can just kind of skip them. If I hit the home button, that'll bring us back to our home page. And now we're ready to run a job. Now we're going to go over file setup and file prep. There are a couple of caveats. First, we have to start with a DXF drawing. Those DXFs can't have any imagery in it. So you'll want to use a drafting software, something like AutoCAD or Rhino or Fusion 360 or SolidWorks to make that DXF, and then we'll load them into our Fab Creator software. Things like images tend to make the software behave erratically. So we can't really do images. It has to be vectors and vectors only. So we'll go ahead and we'll start up our Fab Creator software. And then we'll say File, and we're going to import our DXFs. And hit Open. And typically we'll get some messages about whether or not we want to choose inches or millimeters. You have to make sure that your DXFs are in inches, either inches or millimeters. If they are in any other unit, if they are in feet or miles or parsecs, you're going to have a bad time. So please try and keep your files situated in either inches or metric millimeters. When a file opens, it typically is put everything into a kind of part folder. If we expand that parts folder, we can see there are three categories, technically four. We've got our cut folder, we've got engraving, and we've got rastering, and then finally a reference folder. These will correspond to the different types of cuts that we're going to do. So each of these, if we expand those, have a collection of lines or polylines or curves, and essentially they'll be cut on those layers. So the way that this software works is it's going to start with the rastering, and it's going to start at the top of the list, and it's going to raster everything in that list. Then it's going to jump to engraving, and it's going to start at the top, and it's going to work its way through each of those lines all the way to the bottom. And then finally, it's going to jump to cut, and it'll start at the top and work its way to the bottom. Now, this is kind of critically important that we make sure that our cut order is the way that we want it to be. If we, for example, on this drawing, if we, for example, cut the outside circle first and then cut the inside circle, the outside will potentially drop into the base in the machine, and then it'll go to cut that inside circle without any material there. And then we'll have that condition where the laser is firing directly into the backstop of the machine, and that's not good. We don't want that. So we have to make sure that the cut order here is exactly as we want it, and then we can be sure that that it'll do exactly what we predict it's going to do. So if you need to make changes for whatever reason, you can just drag and drop to reorder. So In this case, right now, I just reordered these, and now it's going to do the outside first, followed by the inside. And we don't want that. So I'll just reorder that back to how it was. So the inside cut first, outside cut second, and we're good to go. We can also move these around. So if I want to go from rastering and I want to make sure that they're all engraved, I can do that. Or I can move them all from here into raster, and then it will raster all of those as well. In this case, I'm going to leave this middle one to be my raster, and then I'm going to take these other ones and put them in the engrave folder. So it's going to shade this middle one solid, and then it's going to score all of these ones into the surface. And then finally, it's going to cut out the whole thing. And we're happy with this ordering. So from here on out, once we've kind of situated the file so that all of our lines are where they're supposed to be, at this point, we can just march through these different tabs. We've got edit, we've got properties, we've got process, and we've got job. And so we'll go in order. If we click on edit, we have a couple of edits that we can do here. Move and rotate does not work, so you can largely ignore that. Move to origin does work. So if your parts are floating in space and you need to move them down to this origin point, you can go ahead and click this move to origin and click move to origin and OK, and it will move it to where it makes sense. And then finally, delete and text are here, but they don't really work as well either. So we can kind of like largely ignore this tab. Now, if you do need to rotate your parts, if you do need to make changes, you really have to go back to the software you originally drafted it in and rotate or move or copy your parts there before bringing it back into the software. So we'll move on to our properties tab. This is our critical tab where we actually assign the properties to the cut. So we're going to choose the database, the FL4500. That's this fiber laser, the 4500 watt fiber laser. And then we'll choose the type of cutting that we're doing today is sheet cutting. If we wanted to do tube cutting, we would select tube cutting, and then the interface changes for tube cutting. However, today we're just going to be talking about sheet cutting. And then we want to choose our material. So in this case, in the machine, I have some aluminum already set up. So we've got aluminum 6061. This is where we can see our different material types. So we've got stainless, we've got copper, we've got steel, and we've got titanium. In this case, I'm going to choose aluminum 6061. There are a couple of different material types that we can choose from. So in this case, we've got typical or we've got anodized. I know that this is very typical aluminum, so I'm going to choose that. Next, we can choose our thickness. And this is actually a critical, important dimension. If you make a mistake on the thickness of the material, there's the potential that the laser will fire into the material and reflect back up into the machine. And that's not good. We don't want that. So we're going to choose 60 thou 0.0630 inches because that's the material thickness that we have in there. We have size X and size Y, which represent the bounding box of our shape. Now, we could change this to be something else, the representative of our sheet, for example. However, as soon as you move to something else, it will immediately revert back to the bounding box of this shape. So we'll go ahead and leave it at 1.5 by 1.5. Next, below that, we have a tab that doesn't do anything. So engrave settings, this doesn't do anything. You can ignore it. Below that, we actually have our raster settings. Now, this is actually kind of critically important too. This describes the DPI in the X direction and the DPI in the Y. That's dots per inch. So in this case, by default, I believe it's 200 DPI by 625. This produces lines in the surface because we have non-square dots per inch. So I typically recommend making these square numbers. So 625 by 625 will produce a nice even shading in the surface. If you go higher than that, you're not going to make a better raster image. Instead, you'll just be introducing heat and time into the parts. And when you introduce heat and time into metal, the metal has a tendency to warp out of shape, and we don't want that. So I would say for all intents and purposes, 625 by 625 is roughly the maximum for raster engraving. You can go lower than that. So you can go to 300 by 300, for example, and you'll just get a lighter shade of rastering in the surface. If you go down to something like 10 dots per inch by 10 dots per inch, it'll be very light, almost non-existent. So that's how we can control the dots per inch for the raster settings for this part. Also, you'll notice that we can't change raster settings for different shapes. It's kind of all one raster setting for the entirety of the file. So everything gets shaded the same color. Cool. So we'll go ahead and hit accept. And this brings us from the properties tab to the process tab. This is where we can assign tabs and we can turn on or turn off kerf compensation. The tabs in this case are breaks in the cut. So I'll delete all the tabs and I'll go ahead and click insert. And I'll put a couple of tabs here and here. Now, these are just going to break the cut and keep this part connected to the rest of the material. It is critical that you tab everything. If the part that you're cutting or the hole that you're making is about the size of a quarter or larger, you have to put a tab on it. You can put lots of tabs on things, they pop off very easily. However, if you forget to put tabs on things, what happens is your parts tend to fall into the bin of the machine, and then you're gonna go have to find it and retrieve it later, which is very annoying. So you can prevent that from happening by putting tabs on everything. Also, on circular type cuts, the laser has a tendency to cut it, and then that circle doesn't fall into the machine, but rather it tips up, and then the head could potentially run into that material, and that would not be good. Put tabs on everything. You can delete all the tabs. You could click insert and put them on the sides, for example. You could do lots of them. You could do a few. In this case, I know that about 2 tabs works very well. Cool. So we'll hit done. And next, this brings us to the kerf compensation. Now, the kerf compensation is how the software is going to bias the laser to one side of the cut or the other to compensate for the diameter of the beam itself. In this case, the radius of that beam is 5/1000ths of an inch in the radius, 10 thou in diameter. So if we actually zoom in really close here, we can see the green is what I've drawn, and the white is that compensation, moving that laser to the outside of that cut. So you don't need to draw your parts to try and compensate for the diameter of that laser or the radius of the laser. You can just draw it at the size that you need it at, and then this software moves it accordingly. Also, you'll notice that on inside cuts, it's going to move that, it's going to bias the laser to the inside, and on outside cuts, it's going to bias that laser to the outside. So this is very handy. If you're trying to cut on center, if you're trying to make sure that the line that you drew is exactly where you want the middle of the beam, we can turn off kerf compensation, and you'll see that those white lines, those offsets disappear. However, I do not recommend this at all. I recommend that you always keep kerf compensation on. Okay, cool. So we're happy with our processes being delineated. Now we can click on job and we can get ready to cut this thing. So if I click on show job preview, this will give us a decent preview of what this cut is going to look like. We can see that it is indeed raster filling this inside, and then it's scoring or engraving on the outside, and then finally it's going to cut out our part in green. And we like this. This is a good kind of sanity check. We can turn off, we can click hide job preview to turn off that preview. At this point too, if we wanted to make many copies of our file, we can go ahead and click step and repeat. And then we could do 3 by 3, for example, and then hit apply. And then now we have a grid, a 3 by 3 grid of our part arrayed. And we can click on show job preview if we want to see what those look like arrayed. However, today we're just going to cut one of these. So I'm going to turn off step and repeat, and I'm going to click hide preview. And we're happy with this. This is going to run about 59 seconds. It's 063 aluminum, and it's 1.5 inches by 1.5 inches. So we're ready to go. We can hit make and save to make that fab file. So we're going to save this to our flash drive. And hit save. And now we're ready to cut. Okay, so we've prepped our file. We're ready to go. We can go ahead and take our USB, plug it in directly into the controller. And then we're going to go ahead and select our new job. And then now we can go through, we can find our file. In this case, it's this one. And I'm going to go ahead and hit select file right here. So this is going to bring us to a table that shows us what we're doing on all of our processes. So we're cutting, we're engraving, and we're rastering. You'll notice some little lock symbols right here. This is going to prevent us from changing the settings. For the most part, they're kind of locked in and they're ready to use. So you don't really need to change anything about the machine itself. If we want to click preview file, we can go ahead and click this preview file button right here. This will show us a kind of image of what we can expect the machine to do. This is also in 3D, so if we want to tilt around and make sure everything is flat, we can totally do that. We're happy with that, so we can go ahead and hit that check mark in the corner. And so yeah, this is also telling us that we're cutting aluminum, typical sheet, and it's 0.63 in thickness. So we're happy with all of these settings. We can go ahead and hit that check mark. This is going to show us the same kind of window as our jog screen, but now we'll notice that there's a little green square representing the bounding box of our object. And so what we're going to do is we're going to position that somewhere in the machine over some material, and then we're going to cut it at that location. So some machines use absolute coordinate systems where you want to locate your drawing in reference to some zero. This one uses kind of local coordinate systems, so you can kind of just move your part to where you need it and then cut it at that spot. Typically, you may have a sheet of aluminum or a sheet of metal that has a lot of parts already cut out of it and may look a little bit like Swiss cheese. So you want to be able to situate that part somewhere on that piece of Swiss cheese metal. So we'll go ahead and slide the machine around until it's over a piece of metal that we can cut it at. So now we're ready to run our job. We've positioned our part essentially where we want it. At this point, we can go ahead and hit run job and then start it. Or we can turn on dry run. So there's this little toggle right here. If we toggle that, it's going to allow us to run the machine without actually activating the laser. This is really good as a sanity check if you're just trying to figure out where the laser is going to go and you want to make sure that it's going to be on some metal. I definitely recommend running dry run. In this case, I've already run a dry run, so I'm happy with this part. I'm going to go ahead and untoggle that dry run. So now we're ready. We can go ahead and hit run job. And then you'll notice the green start button is flashing and it's ready for us to press. So we're going to go ahead and press that. Now, while this machine is running, at any point, we can go ahead and hit that stop button, and that will effectively act as a pause. A couple of things to note is the vacuum will turn itself on and turn itself off after the cut. When the vacuum turns off, that's when it's ready. You can go in and retrieve your parts. The vacuum is pulling in all of that small particulate matter into the HEPA filter, and we don't want to open the door before the vacuum is turned off because we don't want to breathe all of that small particulate matter, all that metal dust into our lungs. The start and stop buttons, if you hit stop, it'll pause the job. It'll retract the head and wait for some additional input. If you're happy with how it's cutting, you can go ahead and resume by hitting that start button again. Or if you want to quit completely, you hit the stop button again. And that brings us back to our kind of main page. The machine has completed its run. It's cut our part successfully. A couple of things to note: if during the cut you see sparks shooting above the part, definitely stop the machine immediately and let one of us know so that we can take a look at the machine. Typically during a cut, you should see sparks shooting underneath the material and away. That's how we know we get a good cut. If it does anything else that's unexpected, stop the machine and come find one of us to take a look and fix it. Let's retrieve our part. So we'll go ahead and open the part door and slide the bed out. And then parts should just pop right out because those tabs are really small. So the parts are just finished just like that. And we're happy with the result. Make sure we push the bed back into table mode and then go ahead and close the part door. To shut the machine down, make sure we don't leave the head where it is, wherever you cut on the machine. We're going to go ahead and slide it back to as close to the origin as possible. So we're going to slide over all the way to the left-hand side and then all the way to the forwardmost corner. And now we're ready to shut down the machine. To do that, we're basically going to reverse the process. We're going to press our emergency stop button. We're going to turn off our air, and then finally we're going to turn off our white power button. So emergency stop turns off the machine, air turns off, and then finally we turn off the white power button. And now the machine is off in a safe state and your part's completed in your hand and you're ready to go. If you want to order materials, you can order materials on store.jacobshall.org. If you want to reserve time on this machine, it's every Monday, Wednesday, Friday, and you can reserve time on reserve.jacobshall.org under the Fablight. And if you have any questions, come see me. My name is Cody Glen. You can email me at codyglen@berkeley.edu, or come find one of us design specialists in the lab, and we'll be happy to take a look at your projects.